Okay, so in the first year, after the first year, a number of baby magpies, we don't know how many, start to visit Hank's garden. It may be assumed that each of these baby magpies visits the garden randomly and independently. The number of times each baby magpie visits the garden per month is modeled by a Poisson distribution with mean 2.1. That's important. Let's underline that. 2.1. Determine the least number of magpies required, including Bill, in order that the probability of Hank's garden having at least 30 magpie visits per month is greater than 0.2. Right, that sounds... Well, it is complicated. It sounds complicated too, but... Okay. So... Let's consider... one baby magpie. So imagine there was one baby magpie. Let's call it M1. So M1 would have a Poisson distribution of 3.1 plus 2.1, because there's the baby, but Bill as well is still coming, and he comes with on an average of 3.1 times per month. It's a Poisson distribution of 3.1. So both of them coming, I just add the two means. So that's 5.2. That's a Poisson distribution of 5.2. Okay. What's two, let's say two baby magpies. Consider two. Let's say M2. So M2 would be a Poisson distribution of 3.1 plus 2.1 plus 2.1, which would be a Poisson distribution of, what's that, 7.3. Now, the way we're going to figure out this is it's kind of like trial and error. You used to need to know how to use the formula for the Poisson distribution. You don't now, although you could do it that way, but you're not expected to know how to do it. You're not expected to use the formula, so let's just do it this way. Let's use, let's go to our distributions, and we'll go to our Poisson CDF. Now imagine our lambda was 7.3. Now when he says at least, let's say at least 30. Let's say at least 30 magpie visits per month. So that means the lower bound has to be 30, and the upper bound is something big. Let's put in 9999999. There's definitely not going to be, that's like what, 9 million, nearly 10 million magpies. That's not going to happen. So that's a big enough number. Press OK. Okay, he doesn't even like that. Let's try again. That was probably too big a number. I just copied and pasted that, guys. Let's try that. Okay, so the probability that you're going to get more than 30 magpies if there's only two baby magpies is tiny. That's like 2.6 times 10 to the power minus 10. It's not going to happen, right? So instead of, well, we need to find out what is the smallest number. How many 2.1s am I going to add so that this probability will be more than 0.2? More than 0.2. So now let's consider n baby magpies. Okay, so m baby magpies, let's call it m of n, is a Poisson distribution. Now it's 3.1 plus 2.1 times n. That's it, and I need to find this n. So let's just change it. Let's just change this. So I'm going to copy and paste this again. Copy, paste. But instead of 7.3, a mean of 7.3, I'm going to do 3.1 plus 2.1 times. Now, what would be a good guess? How many magpies would we need? How many baby magpies for it to be, I don't know, likely that 30 would come? Well, let's try 10. I actually genuinely don't know the answer here. I'm just going to go with 10. Like they are coming at an average of twice 2.1, which is twice a month. So if there was 10 magpies, 20 a month. This guy's going to come 3 times a month. Probably too low, but let's try it. Okay, 0.136705. It is too low, but at least that gives me something to work with. Well, actually, let's copy and paste this now. I hope you understand, guys, what I've done here with this 3.1 plus 2.1 times 10. So I'm going to change this 10 now to, let's try 12. Okay, that's too big. Let's try 11. It's too big because it's more than 0.2. So actually, the answer is going to be 11, guys, because this is 0.25. Okay, right, good. So when n equals, let's say 10, when n equals 10, the probability that mn is greater or equal to 30 equals 0. This was when n is 10, so it was actually a very good guess. 0.136705. 0.136705. And when n is 11, the probability that mn is greater or equal to 30 is equal to, and you have to write both of these down, 0.253384. 0.253384. You have to write the 10 one down as well to show that you understand that this is the smallest one, because it's the least number of magpies required so that the probability is more than 0.2. Because look, if n was 12, it's more than 0.2. If n was 20, it'd be more than 0.2. But they want the least number of baby magpies so that the probability would be more than 0.2. So that's the least one. Hence why I've written this down as well, because that shows that when n is 10, it's below 0.2. When n is 11, it's above 0.2. And that's it. So I write, therefore, the least number of magpies, okay, be careful, guys, actually, though, because it says including Bill. Right, I actually nearly missed that. So least number of magpies is 11 plus 1, which is equal to 12. So 12 is the least number of magpies, such that it would be greater than 0.2. Okay, hope that makes sense. See you for the next question.